Welcome back to True North Mechatronics. In this episode of the TitanBot series, we are fortifying the logic core of our drive electronics. We are engineering the Citadel Door Panels to allow airflow past the L29 3D driver chips, as well as continuing to build out the aesthetic of our Humvee-inspired shell. Now, a rookie mistake in robotics is designing a shell that looks cool but makes the robot a nightmare to work on. If you have to undo 6 screws just to plug in a USB cable to flash your code, you have a poor design. So today we're focusing on design for serviceability. We're going to model these panels with precise apertures that align with the USB port on our Arduino Uno, allowing for rapid updates in the field. Design, engineer, deploy. Let's get into the CAD. Begin by creating a new body and a new sketch. We're going to put that on the XY plane. And we're going to rough out the outside of these panels with a rectangle. We're going to make this rectangle symmetric with respect to the origin. And we're going to constrain the width of this rectangle to be 64 millimeters, and we'll constrain the vertical height of this to 41.4 millimeters. Next, we're going to grab our polyline tool, and we're going to rough out the apertures for these door panels. We will modify the horizontal and vertical constraints after we've got these roughed out. This shape needs to be printed so that the angular parts of the panel are facing forward. If you happen to print a duplicate of this part, all that will happen is that your windows or apertures will be facing backwards. So, depending on how you want your final robot build to look, you're going to have to be aware of this. Alright, we're going to make the top of these two apertures collinear with each other. We'll do the same with the bottom of these two panels. Next, we're going to set all of these horizontal portions of the shapes. They're equal to each other. And we'll do the same with the vertical sides of these shapes. Now that we have those, the last thing I'm going to do is I'm going to make sure that these two slanted portions here are parallel to each other. And now, so that I can focus on the dimensioning of this, I'm going to hide these different constraints. I'll bring back the first constraints that we put in that gave us our outer dimensions. Now let's dimension the apertures. So let's create a dimension on the top of 15 millimeters. We're going to constrain the overall vertical length to 20 millimeters. We're going to constrain the total vertical length of this to 26 millimeters. And we're going to constrain the overall width of this shape. We'll constrain that to 22.9 millimeters. Alright, so now that we've got the aperture roughed out, we're going to create a distance between these two apertures of 6 millimeters. Sometimes FreeCAD likes to interpret what it is that you're clicking on. So once you've got that shape, just miss the y-axis there and click. And there we go. 6 millimeters. And the next thing that we're going to constrain now is the distance of this aperture from the edge of our panel. So I'm going to select these two vertices, and we're going to give it a distance from the top of 7.5 millimeters. Let's double click on that and change that. 7.5 millimeters. And we're going to set the offset width to 6.1 millimeters. And with that, we've fully constrained the apertures that will show up in the door panel, and we're ready to close out of the sketcher and move on to the next part. Alright, let's pad this shape out to 3 millimeters. And we're going to add 4 tabs to the top of this. These will be used for connecting to the vertical frame rails, as well as creating mount points for the top of our Citadel. So we're going to use the external geometry reference tool. We're going to reference that edge of the door panel aperture, and we're going to reference the top edge of the door. Now we're going to use the rectangle tool, and we're going to create 4 rectangles. All these rectangles are going to have an overall thickness of 3 millimeters, so we're going to set them all so that they're the same to begin with. All right, so they're all going to be 3 millimeters thick. The top panels are going to be the same width, and our side tabs here, these mounting tabs, are going to be the same as well. We're going to create a line of symmetry here with the y-axis, and we're going to make it so these two outer tabs are symmetric there. We're going to do the same thing with these top tabs, so we'll make them symmetric with respect to the y-axis. Now let's do some dimensioning of these tabs. So let's set the overall vertical length of that to 10 millimeters. We're going to set the top horizontal width to 8 millimeters, and we will of course set the thickness there to 3 millimeters. Now that we've got that, now we're going to create an offset at the top here. So we're going to select these two vertices here, and we're going to set this distance to 30 millimeters. That constrains those. We need to set the offset from the top for these tabs here. So I'm going to select these 2 points here, and I'm going to create an offset from the top of 8 millimeters. And with that, our tab shapes are fully constrained. We can close out of the Sketcher workbench. And we're going to pad these out to 9 millimeters. So the next thing that we're going to do is we're going to create mounting points for our PT screws. They have a minor diameter of 2.8 millimeters. Going to reference the outer edge of the tab we created, and we will make the diameter of that hole 2.8. We're going to constrain this hole so that it is symmetric inside of our tab. I'm going to close out of this now, and we're going to pocket both of these tabs at the same time. Distance of 58 millimeter will clear that pocket all the way through the shape. We need to add the mounting holes on the top of the panel. This is where the top of the Citadel will be screwed onto later. So we'll create 2 holes. These mounting holes, again, are going to be constrained to a diameter of 2.8 millimeters. We'll make both holes so that they're equal to each other, and we'll make them symmetric with respect to the y-axis, which has the fortunate side effect of also making them collinear. So we only need to constrain one of these on the tab because these tabs are symmetric with respect to the y-axis. And so there's both holes constrained, and we can pocket these. All right, so now we're ready for building the top of the Citadel. One last thing that we need to do is create an anchor point down here. This will connect to the kinetic tray, logic tray that we built earlier. So create a sketch on the top there, and we're going to create a single hole down here. And this one, of course, is set to 2.8. Actually, we'll set this one to 3.2. That's the major diameter in the PT screw. And we'll reference the bottom of the panel. Let's try that again. Reference the bottom of the panel, and we're going to create an offset from the bottom of 4.5 millimeters. All right, now that anchor point is fully constrained, so we can close out of this, and we can pocket that shape all the way through. Okay, and so now that we have a fully complete panel, we need to create the complementary side, so the other side. So if this is the left-hand side panel, we're going to create the right-hand side panel. To do this, we're going to select the body from the model panel. We're going to go up to our workbench selector, and we're going to choose the draft workbench. And from the draft workbench, we're going to click on the clone tool. We're going to set the scale to -1 in the y-axis. This is going to give us our complementary part, our mirror part. So let's click on that, right click, and transform it. I'm just going to move it out into view so that we can see it. So there is our mirror part. I'm happy with that transform. And we have completed the Citadel door panel. This is going to provide us with the thermal venting that we need around the motor core. Chart your course, build your world. See you in the next one.